Hi everybody, and welcome to this short presentation of an enhanced version of the terrain or surface rendering algorithm which I have developed, with the simple and clear purpose of helping those who may need such a functionality in a program they want to develop. And well, this time is the turn of multi-threaded programming to allow achieving a better performance of the program and thus also a better overall graphical quality. Of course, multi-threading in a certain way also reduces the hardware requirements to achieve a certain overall quality. Since a computer with a couple of moderately powerful processors is cheaper and more common than a computer with fewer but more powerful processors. You can really forgive me if I don't show it to you with a really low end and also really old computer hardware. But the monitor is put at some use, which is, I think, just as noble as the other one would be. Three, two, one, go. This time, for a change, I did most of the footages with this quite unusual texturing system, which proved also most adequate to accompany this algorithm anyway. At the beginning I thought too that this kind of texturing of the surface is disturbing and inefficient, but I re-evaluated it and concluded that with this algorithm this kind of texturing works well. Since the detail tends to accumulate along sorts of edge lines which are exhibited by the surface, the coloring tends to be precise in those places. And of course, since the really relevant information is around the edge lines, it's sufficient that the coloring be very precise there, while an additional bulk texture applied across the triangles can help to make it all look more natural. Even if it does not look as good as classical texturing, it's much lighter both on memory usage and number of operations, and it can be done perfectly well even with full streaming access to the texture data. As long as my deductions went, it's the fastest and at the same time simplest type of texturing conceivable in the context of this rendering algorithm. So, it's certainly at least worth of consideration. So, even if classical texturing can be used as well, the good thing is that this root kind of texturing can be used too. In fact, according to what I tried to outline a little before, it gives any acceptable results only with the particularly, let's say, contour-friendly kind of triangulation scheme which features in this algorithm. More on this topic later. Let's go on. For this flavor of the program, of course, still hold the things said in the previous video on the topic, mainly that this algorithm is suited for rendering in real time very large terrains with a very low memory usage and also quite low computational speed in general, independently of the terrain size which potentially has no limits, even if in this version the limit is a height map made of 8000 by 8000 height samples, mainly because in this version the SDL library is used instead of the libpng library to read the height map stored as a PNG file. So, it's still true that in the algorithm my first and second theorem about polygonal surface approximation are used. And according to theorem 1, stage 3 and 4 spontaneously split into major subtasks which can be done independently, for which it is sufficient that these two subtasks are coordinated correctly. This time, thanks to multithreading, these are implemented as such. And there, the two subtasks are in fact ran on two parallel threads of execution. One could implement it with a more massive parallelism too, and this is interesting from a theoretical point of view, but its advantages are questionable, as further parallelization would become disproportionately complicated with respect to the possible benefits, and most importantly with respect to the striking simplicity of the algorithm itself. While stage 1 and 2 don't need any parallelization because they are two tasks which are computationally much lighter, even if this could be parallelized too, and this would also be much simpler to do than it was for stage 3 and 4. At the time when I wrote the version which implements the algorithm without exploiting multithreading, I had put forward the option of writing an enhanced multithreaded version only as a remote future possibility. It's the same thing that I stated in the video presentation of the plain non-multithreaded version. But fortunately, as soon as 3 weeks or so later, I started to work on the enhanced version, mainly because I wanted to provide absolutely certain facts about the real possibilities and to arrive at a well-optimized final product as soon as possible. It was ready and tested in 1 week, so it's here. Of course, both flavors will be released, but this multi-threaded one is absolutely better for multiprocessor computers. With regard to those who can't get used to the texturing style presented earlier, this footage is done with classical texturing. Hope you like it. As mentioned earlier, of course, one can use also classical texturing, but that topic is not discussed here, and it shall be addressed in some future video. Classical texturing looks often better, but in most cases it just does not get along really well with this algorithm, since closer blocks are not necessarily also smaller, and since there are in fact blocks of very different sizes very close to each other, most of the cases, classical texturing becomes hard to do well and fast. Said very roughly, when there are very big blocks near very small blocks, we would need to put very large textures on the larger blocks, and loading, storing too large images to use as textures is just not safe, and it's also theoretically ill-stated. An exception, to some extent, is a typically top-down application such as a 3D map program, where textures don't reach any detail significantly greater than the very height map's coloring plus some extra decoration, so to say. In these cases, all textures would be moderately large, and for blocks larger than a prefix maximum, a bulk texture could be put. So, let's come to an example featuring a 3D map. I've prepared 2 datasets to make all footages worth every minute of this video. I took 2 8000 by 8000 subsets from the Puget Sound 16000 by 16000 dataset. Now, footages be accompanied by a final discussion. I know that today
tendentially top-down applications may be considered obsolete, but of course that's not true, because just think to how much can be made out of the advantages of the top-down view with modern technologies. We can have a true 3D map program, and yeah, actually we can do these kinds of flyovers, and thanks to the fact that there is perspective, and of course thanks to the fact that the camera can be a little bit inclined according to the direction in which it is dragged or so, and thanks to the perspective and everything, just it looks more holographic, but we can of course just span great distances and then say, okay, I'm curious to see what this looks like, and we can zoom the camera, we can get closer further, and that can be done only with an advanced terrain rendering system such as this one, and with a computer which is sufficiently fast, powerful to allow running such a program, and that's something really incredible. And here the advantages of the top-down view can be exploited to put, for example, a much higher resolution texture, which of course must be loaded dynamically, and yes, all that's possible. A 3D map program which this rendering algorithm is especially indicated for, because one can have a fairly good control over what details are seen, because the view distance is adjusted according to how far we are, and thanks to this one can do one can use a full streaming kind of access to the height map, which is slow, but since we have tendentially only a moderate amount of detail, yeah, we can spare time to allow decoding in a sort of full streaming fashion the height map, and we can access areas even much greater than this in real time, and then we see, there is a nice site here, I want to see what it looks like from close, and yes, one can do it. And with a 3D map program, unlike with a plain geographic map, one can of course modify the program to produce a stereographic picture, you know, those things for stereographic view, or the blue-red too, or an image to be inspected with a blue-red glass and see it in stereo, and that's, I think, would make a lot of impression. And all this is possible in real time because we use a fairly heavy rendering algorithm, but we take advantage of the assumptions we can make thanks to an almost perfectly top-down view. And with this kind of view also more detailed textures can be loaded, because most of the times we know, first of all, we have less detail, and most of the detail is provided by blocks of not too much different sizes. And so we can see, okay, we have tendentially blocks of which are like blocks which are from the triple to the tenfold per side length of with respect to the smallest blocks, and we can really know what textures we have to load, and we can choose the scale. That's fine. Not to mention that with the top-down view, most of the times we can have the 1 pixel tolerance, which gives excellent quality both in the approximation of the surface, which in that case most of the times is an exact reproduction of the surface, and also higher speed in the transitions in the level of detail, so we can have something really high quality, and we can do these flyovers even in the most tortuous parts of the terrain without problems with the frame rate and too much visible transitions in the level of detail. Look, 1 pixel, even if we are in one of the absolutely most tortuous parts. And when we let the camera go into such a kind of 3D mech program, when we let it go a little bit, maybe on the camera it's not too much visible, but it gives, thanks to perspective, a sort of more, let's say, 3D impression, more holographic impression, because thanks to perspective, of course, we can actually see the height of an object, because thanks to perspective, things at different heights move at different rates, and that's really cool. And yes, I wanted to show it to you, and okay, I will be working hard with the development of another version of this implementation of the algorithm, in which the height map is actually loaded in a full streaming fashion, exploiting the fantastic features of the PNG file format. And so hope you liked all this, and bye bye.